So if you were to ask financial analysts just a year ago, they'd have told you the humanoid robot market was, well, decades away.
Oh, at least, yeah. It was still total science fiction to them.
Right, but now.
Huh.
By 2035, those exact same analysts are projecting that 1.4 million synthetic workers are going to be rolling off assembly lines every single year.
It's a massive shift. I mean, the entire timeline just collapsed.
Completely collapsed, and that's exactly what you're getting into today.
Yeah.
Welcome to the deep dive. We are unpacking the $20 trillion humanoid robot race for you.
And we really want to get past just, throwing statistics at you.
Exactly. We've got a really wild stack of sources today to figure out why this is happening right now. We're looking at Tesla's colossal Q4 2025 financial update, a radically revised 2024 Goldman Sachs report.
Which is fascinating on its own, honestly.
Oh, definitely.
Yeah.
Plus, we have this really insightful Polish market analysis and a recent RCVEV research paper on vision language action models.
Yeah, that paper is the key to all of this, really.
Yeah.
It explains the brain aspect.
Right. So our mission today is to figure out how these robots suddenly got their brains, the surprising math that's making them affordable, and why the whole tech world is pivoting so hard into physical AI.
It's like we're standing at the exact tipping point. Like the days before electric vehicles or generative AI really took off.
Yes. It's the smartphone phase of mass adoption, but for humanoids. So let's start with the science. Because before we talk about how many millions of robots are going to be sold, we have to understand why this is suddenly possible.
Right, because for decades we've had the hardware. I mean, we could build a mechanical arm.
But it was effectively dumb, right? Like a brilliant mechanical body is totally useless if it doesn't understand its environment.
Exactly. Anyone who follows robotics knows the old problem. Making a machine just pick up a cup meant an agonizing amount of hard coding.
Just to pick up a cup.
Oh yeah. Engineers used inverse kinematics. They had to calculate the exact geometric angles for an elbow and a wrist to reach a specific XYZ coordinate in space.
So wait, if the cup was bumped like 2 inches to the left?
The robot would just blindly grasp at empty air. It had no semantic understanding of what a cup even was. It was just running a geometric script.
Wow. Okay, let's unpack this. Because the RCVEV paper on vision language action models, or VLAs, basically says that's all over now.
It is. VLAs are the foundational leap. Historically, you had vision systems, language processing, and motor control, and they were, totally siloed fields.
And they didn't talk to each other.
Barely. But a VLA model unifies them into one single system, one continuous vector space.
So instead of having a camera module trying to translate data to a text module, the AI processes the physical world the exact same way a large language model processes a paragraph of text.
Exactly. It tokenizes everything.
That's wild.
Yeah, so when you tell a VLA-equipped robot, like, hey, sort the defective parts, the language model understands your intent. But simultaneously, the vision model is parsing the live video feed.
And it's not just seeing pixels, right? It actually recognizes the concept of defective in 3D space.
You nailed it. And then the action layer translates that visual and semantic understanding directly into the physical movements required to do the job.
The Goldman Sachs report actually calls this end-to-end AI.
Which is a huge deal.
Yeah.
The model basically trains itself.
Right. No human needed in the loop to intermediate code. It's basically like teaching a teenager to drive.
That's a great analogy.
You don't program a teenager's muscles to turn the steering wheel exactly 12 degrees while applying 4 pounds of pressure to the brake. You just say, hey, stay in the lane.
And their brain just figures out the mechanics on the fly based on what they see out the windshield.
Exactly. But wait, I want to push back on this for a second. If they don't need task-specific training, does that mean the exact same robotic brain operating, say, a heavy factory robot could theoretically learn to fold my laundry at home just by looking at it?
What's fascinating here is...
Yes, absolutely.
Wait, really? The exact same brain.
Wow.
The exact same architecture.
Yeah.
And that's what the Polish market analysis points out as the most monumental shift in this space. We are completely moving away from narrow, single-purpose machines.
Because a robot arm that only knows how to weld one specific car door is a dead end now?
Exactly. We are looking at the very first general-purpose workers in technology history.
A general-purpose worker. Wow. I mean, let that sink in for a second. That totally rewrites the economics of human labor.
It does. But, having a genius robotic brain doesn't matter if the body costs $1 million.
Right. Which brings us to the business logic, the math of profitability. Because no warehouse is going to buy $1 million robot just to sort boxes.
Definitely not. And that's why the Goldman Sachs revision is so crazy. They had to completely rewrite their forecasts.
Yeah, in the 2024 report, what did they originally project for 2035?
Just a year prior, they thought the humanoid market would be around $6 billion by 2035.
$6 billion, and then they revised it to what?
$38 billion. They increased it more than sixfold. They're now projecting 1.4 million robot shipments annually.
That is a staggering jump for a financial institution to make in just 12 months. Why did the math suddenly work?
Because the cost to build a humanoid crashed by 40% in one single year.
40%.
Yeah, analysts were expecting maybe a 15 to 20% drop, which is standard. But 40% just blew the models apart. We went from these bespoke, hand-built university prototypes that cost like 250 grand down to a projected range of $30,000 to $150,000.
Okay, but how does the price fall that fast? Did titanium just go on sale?
No. The Polish text explains this really well. It's a classic learning curve. Early robots were built with custom machined parts, hand-built actuators.
Very boutique.
Super boutique. But now companies are tapping into the massive electric vehicle supply chain. If you're already making 1 million electric motors for cars, scaling down a standardized motor for a robot elbow is cheap.
Right, it's all injection molded components and centralized compute now.
Mass assembly lines. More production equals lower costs.
And lower costs mean you can sell more robots, which means they gather way more real-world data, which makes the AI smarter, which drives up demand even more.
It's a massive feedback loop.
Here's where it gets really interesting, though, because even at the bottom end of that Goldman Sachs estimate, $30,000, that's still the price of a brand new car.
It is.
So if I'm running a business, are you telling me I'm going to buy these things by the millions just to sort components? Why not buy a wheeled robot for a fraction of the cost? How does the ROI actually make sense for a bipedal robot right now?
Well, a wheeled robot is great if your environment is perfectly structured, like a brand new, flat, grid-based automated warehouse.
Sure.
But the real world is messy. Factories have stairs, tight corners, cords on the floor drop pallets. A wheeled robot gets totally stuck if a piece of cardboard falls in front of it.
Oh, right. And a humanoid just steps right over it.
Exactly. Plus, Goldman Sachs highlights a massive labor shortage angle. They project a 4% manufacturing labor gap in the U.S. alone by 2030.
Wow, 4% is huge when you're talking about the entire manufacturing sector.
Right. Add in the aging populations across the globe, and companies are going to be desperate. They will pay a premium to fill the 3D jobs.
The dangerous, dirty, and dull jobs, like chemical manufacturing or disaster rescue. Places where human labor is just too scarce or too risky.
Exactly. You don't have to redesign a 100-year-old factory to fit a humanoid. The environment is already built for us. You just swap out the worker.
Okay, so the science is ready, the math makes sense, the labor demand is there. So who is actually building the physical infrastructure to make millions of these things?
That brings us to Tesla's Q4 2025 financial update.
Yes, this document is mind-blowing.
The biggest takeaway isn't even the revenue. It's that Tesla explicitly states they are no longer just a car company. They are transitioning into a physical AI company.
That is a wild shift in identity. The cars are just one application of physical AI now.
Exactly. And they are backing it up. They detailed their concrete progress on the Optimus Gen 3 robot.
And Gen 3 is the one designed for actual mass production, right?
Yeah, it's not a prototype anymore. It has a totally new hand design with tactile sensors, which is crucial for those messy, unstructured tasks we talked about.
And the timeline they put in this report is incredibly aggressive. They're prepping the first production line right now, and they plan to start volume production before the end of 2026.
Targeting an eventual capacity of 1 million robots per year.
1 million. That is just hard to even picture. But building 1 million metal bodies is one thing. Giving 1 million bodies that VLA brain requires so much computing power.
An unbelievable amount of compute. But Tesla is building it. They're building Cortex-2 in Texas, which doubles their AI training compute.
And they just poured $2 billion into XAI, right? To integrate Grok into the physical world.
Yeah, to give the robots that high-level conversational semantic reasoning. So you can talk to the robot just like you talk to a chatbot, but it actually executes physical actions.
So what does this all mean? I look at Cortex-1 and Cortex-2 like a massive digital gym.
A digital gym, I like that.
Yeah, like Tesla isn't just building a factory to screw metal together. They built a simulation where the Optimus brain works out millions of times a second. It learns to walk and grasp in a virtual world, and then they download that muscle memory into the metal body.
That's spot on.
Oh.
And historically, that sim-to-real transfer usually failed because the virtual physics never quite matched the real world.
Right, real floors are slippery or uneven.
Exactly. But with massive compute, Tesla uses domain randomization. They simulate millions of variations, slightly different gravity, random wind, weird friction.
Wow.
So when the brain is downloaded into the real robot, it's already prepared for the chaos of a real factory floor.
If we connect this to the bigger picture, Tesla also has an insane data advantage. The report mentions that through their full self-driving cars, they collect over 500 years of real-world driving data every single day.
Every single day. And people always ask, why does car data matter for a walking robot?
Right, it seems disconnected.
But a car is just a wheeled robot navigating 3D space. It has to understand object permanence, predict human movements, tell the difference between a shadow and a pothole.
The occupancy networks.
Exactly. The exact same neural architecture that keeps a car from hitting a pedestrian is what keeps a humanoid robot from walking into a forklift. They're basically copy-pasting the software stack from their cars into the robots.
Along with the batteries and the custom silicon. Total vertical integration.
That's a huge advantage.
Which brings us to the craziest insight from all these sources. Tesla making millions of robots is really just the tip of the iceberg.
Selling the hardware is almost a distraction from the real money.
Yeah, because Goldman Sachs sees a $38 billion hardware market, but the Polish analysis points out that institutions like Morgan Stanley project a long-term economic impact in the trillions. Trillions with a T.
The hardware is a rounding error compared to the software. It's the software multiplier.
Let's break that down for everyone listening. With a human, if you spend 5 years training a master welder, you get one master welder.
Right. And if you want another one, you start from scratch.
But with physical AI, if you train one VLA model to do the perfect weld, you just hit copy.
And instantly paste that skill across 10,000 robots globally. The intelligence scales with zero marginal cost. That's where the trillions of dollars come from.
This is the iPhone moment all over again. Apple makes money on the physical phone, sure, but the absolute goldmine is the App Store.
Exactly. The data, the services, the software ecosystem.
So are we literally going to see an App Store for humanoids? Like third-party developers selling a perfect souffle app that you buy for $5 and download directly into your kitchen robot?
Eventually, yes. That is exactly where the industry is heading. You'll have APIs, digital twins, entire app ecosystems.
Wow.
But, and this is important, the sources definitely tempered this excitement with some real talk.
Yeah, because a buggy app on my phone just freezes the screen. A buggy app on a 200-pound metal robot in my kitchen could punch a hole in the drywall.
Precisely. The safety concerns are massive. Plus, there are major battery limitations. Heavy physical labor drains power fast.
And a factory can manage that, right? They can schedule charging rotations, but a consumer at home isn't going to want a robot that works for an hour and charges for 4.
Exactly. So factory adoption will be incredibly rapid. But consumer home adoption, that will take years longer to overcome the safety and hardware hurdles.
That makes total sense. We've covered a ton of ground for you today, so let's just quickly recap the journey.
It's been a lot.
It has. We saw how VLA models finally gave machines a brain, solving the semantic gap. Then we looked at how leveraging the EV supply chain caused hardware costs to just plummet.
Down 40% in a year, making the business case totally viable.
Right. And finally, massive infrastructure investments from companies like Tesla moving from cars to physical AI are turning this sci-fi concept into a scalable, mass-produced reality.
The pieces are all locking into place.
They really are. And that leaves me with one final kind of provocative thought for you to ponder today.
Oh, I like these.
So the sources mention that humanoids are valuable right now because they operate in a world that's already built for humans, right? We don't have to rebuild our factories or our homes for them.
Right, they adapt to us.
But as millions of these physical AI agents enter our world, they're going to be gathering petabytes of spatial data. They're going to find every single physical inefficiency in how we've built things.
Oh, wow. Yeah.
So my question for you is, eventually, will we stop designing things just for ourselves?
Yeah.
As robots become the primary labor force, will the future architects of our cities, our workplaces, and our homes start designing our environments not for humans, but to be optimized for the robots we share them with?
That's a wild thought. A totally different kind of world.
It really is. Something to keep in mind the next time you hear about a breakthrough in physical AI. Thank you for joining us on this deep dive. We'll be back next time to unpack another stack of sources and find the hidden connections shaping our future. Until then, keep questioning the impossible.